Hi, I'm James Easton. Now, normally when I do videos for my YouTube channel, I put a bit of planning in beforehand. I try and think about what I'm going to say. This video is not like that. In this video, I want to talk about how I've been using AI in my developer workflow. Now, I realize everybody is jumping on the AI bandwagon at the minute. This is not one of them kind of videos. This is simply me talking about how I'm using AI as part of my development workflow. I am not trying to shill AI. I'm not trying to sell you anything. I don't actually believe any of the hype, but I do believe it can be an incredibly powerful tool if used in the right way. And there are primarily three different ways that I'm using AI in my day-to-day workflow. The first of those is bootstrapping new projects. Now, I saw an interesting post from Yan Chui on LinkedIn the other day talking about how he doesn't use AI for bootstrapping. Instead, he uses AI once he's got a starting point to give the AI some context for how he wants the rest of the project to be built. And I think that is a fantastic way of using AI. The AIs work best when they have a lot of context of how you want a system to be built. But I've been using Claude Code quite a lot over the last week or so, and I found a really good workflow, I think, for how this can actually work better. And this was actually inspired by a GitHub repo I saw shared on one of the social media sites from Paul Hammond. So big shout out to Paul Hammond. If you're watching this or if you come across this, please know I am fully inspired by what you've done here. And under this, in this .files repository, he's got this example for Claude. And this is a really long Claude.md file that basically talks about a whole bunch of best practices for building with TypeScript. Things like you should always use test-driven development, some key principles for Claude to use, principles for testing, how to organize your application code, how to interact with the database, using Zod for schema-first development. There's a whole bunch of best practices in here that Paul wants to use whenever he's using Claude with TypeScript. Inspired by that, I tried to create a few of these of my own. I've got this GitHub repository of developer prompts. I'll put a link to this in the description if you want to go and have a look at these. And these are really specific, similarly structured markdown files that I can use to give Claude a whole bunch of context at the start of a project for how I want that project to be structured. I've got one here for .NET, one for Rust, and a really rough one for Python that I don't really think is very good. But as well as having this .NET one, I've also got this really specific .NET AWS serverless one. This is very specifically things that I think you should do if you're building with .NET and running it on AWS Lambda. Things like using the Lambda annotations framework, like using dependency injection still, like using native AOT compilation for any APIs to get some really good performance. Now, the specifics in here are largely irrelevant. You can go and have a look if you want. So as far as bootstrapping a new project goes, I'm going to take this existing Claude.md file and I'm going to copy that into a subfolder inside this repository. Make that a little bit bigger. And I'm going to rename that file to claude.md. You'll notice at the top of here, I've got this application features section. This is where I need to add the description of what this application should do. So this is an application that is going to take our request from the user that contains a name and email address and simply store that in the database. Really simple application use case. Of course, you can expand this out as much as you wanted to. From here, now I've got this Claude.md file with the really simple feature that this application needs to have and this whole bunch of context for how you should actually structure the application. I'm going to come over back to my terminal now and navigate into that folder, .AWS serverless, and I'm going to run Claude. This is going to start up Claude Code in my terminal, and you're going to get a complaint that actually the Claude.md is enormous and this is going to impact performance. This is absolutely fine. Claude will still work. If you're running a lower powered machine, it might just be a little bit slow. And then in here, I'm going to switch Claude over to plan mode first. Now, really a useful shortcut if you're using Claude Code is Shift and Tab to cycle through the different modes that Claude has. So I'm going to start with plan mode, and I'm going to say, can you structure me the basic outline of the project to meet your application requirements, use all of your best practices, ultra think about the right way to structure this project. I'm going to hit enter and Claude is going to go off and actually start to work out exactly what it needs to do. I'm going to pause the video here for a little while because this can take a few seconds. Okay, so Claude has now given me some data back. It took about 20 seconds to do this, so not a huge amount of time considering what's going on. And here's exactly what Claude is going to do. So it's going to structure the project with a source folder, with the API, the core domain model, and any adapters. Inside that markdown file, I talk about ports and adapters and separating business logic from infrastructure code. I talk about how to structure the application code separate from the test project. So I've got my source folder I've got my test projects, great. And then it's actually put the infrastructure project under its own directory. I'm not hugely thrilled about that, but equally I'm not really offended by that structure. So what exactly else is it going to do? So it's going to create a contact registration vertical slice. So it's going to have a contact, which is the domain entity, the request, the response, the contact service. It's going to create the Lambda functions using the Lambda annotations framework. It's going to use DynamoDB. It's going to use single table design. Notice it calls out native AOT compilation for performance, structured logging with power tools. It's going to use TDD. It's going to use AWS SAM as its infrastructure. I would use the CDK, but I'm okay with AWS SAM. That's absolutely fine. This all looks good. So I'm going to say, yes, proceed. What Claude is going to do now is it's going to actually go off and start actually implementing all of that stuff. So if I come back over to Visual Studio Code now, and I have a look in my .NET AWS Serverless folder, this is going to start actually generating code files. Whilst that is just happening, the other really nice thing that Claude does is it actually creates this to-do list. So it chunks things down into these really small tasks. So the first thing it's going to do is create the project structure, then create the core project, then create the test project. It's going to go through one by one and implement these to-dos. So the first thing it's going to do is actually create the project structure. I'm expecting at this point Claude to ask me if it's okay to run make directory commands. I'm going to say yes and don't ask me again to allow it to actually go off and create directories. Coming back into here now, I've got my source folder and my tests folder. Claude has started scaffolding out the actual project, also creating my subfolders for the adapters, for the tests. And as this is going through, if you watch Claude in the terminal, you can see that it's completed the first task. It ticks off the to-do, and now it goes off and starts working on the second to-do. Now, interestingly, as Claude is going through this, it's got to the point where it actually needs to start writing application code now. So it's structured all of the files, it's created the projects. And if you notice what Claude is actually saying, I need to follow TDD principles. According to the guidelines, I should start with a failing test first, then implement the minimal code to make it pass. Let me create the folder structure first, then start with a failing test for the contact ID. Now, one thing a lot of .NET projects do is actually inside the folder structure, so inside my core folder, they'll create directories based on entities, services, repositories, interfaces, and I really don't like that as a pattern. I actually think when you look at a code base, you should be able to see exactly what that code base does by just looking at the structure of the folders and the files. If you just let Claude run without that prompting, it will do what a lot of .NET projects do and create a folder called entities, a folder called services, a folder called repositories. Instead, I've got this contact registration folder, and inside there, it's going to create everything related to contact registration. That was in my upfront context that I gave to Claude, which was why Claude has then said, based on the guidelines inside the core project, I should create core folders based on business value, not on technical features. The first thing it's done is created the test as requested. Go and have a look at my tests. None of this should actually pass. I'm going to run .NET Test. I'm going to let Claude run .NET Test. And as you might expect, this completely fails because it's following test-driven development, red, green, refactor, red, green, refactor. So it's tip. And it's even said that, perfect, these tests are failing as expected. This is the red phase of TDD. So whilst that's just churning away in the background, writing some code for me, making tests pass, I'm going to talk about the other couple of ways that I use AI as well. And for this, I'm going to open up my plant-based pizza repository. If you're not familiar, the plant-based pizza repository is a GitHub repository on my GitHub. It's what I use. It's my bigger sample application that I use for a lot of my content, a lot of my talks. There's a monolithic implementation, there's an AWS serverless implementation, and there's an Azure implementation. So I'm going to use my monolithic implementation. I'm going to actually launch Claude. Claude's going to load up all of its context. One of the other things I find really, really useful when I'm using Claude is to actually start diagnosing issues. Let's imagine you've got an application running in production, that application has thrown an exception, and it's a really confusing or complicated exception, and you don't really know where to start. One of the things Claude is really good at is taking that full look of your entire code base and working out where exactly the problem is. Now, I would always use this in plan mode. I don't want code just to jump straight in and start fixing code immediately. I want to actually understand what Claude thinks the problem is. So I might open up my code base, I've opened up Claude, I've loaded all the context, and I've shifted to plan mode again. And imagine I had an exception. Let's say this application threw an exception in production. Could you look at the error and the code base and analyze exactly what you think the root cause of the problem is? Here, I'm not asking Claude to fix the issue and potentially causing more problems because it doesn't understand the context that I have in my head about what the application should do, what the business requirements of the application are. I can use it as almost as a debugger to help me debug exactly where the problem is coming from. This is particularly useful if I'm working in a language that I'm not as familiar with. I was writing some Python code the other day for a little side project. I don't really understand Python very well. I was getting a whole load of exceptions when I shipped the application to Lambda. Actually being able to put that exception, that error into Claude Code and say, hey, analyze this error, explain it to me, that can be really useful to help you speed up your cycles. So that's the second way I found myself using AI more heavily, is helping me understand an issue. Now, for .NET application codes and .NET exceptions, I can typically work this out because I've been working with .NET for nearly 15 years now, but for other languages, this is a particularly useful way to get started. Now, the final way I found myself using Claude quite a lot is actually taking existing code bases that I have, analyzing that code base and suggesting improvements. Let me show you what I mean. So inside this same plant-based pizza repository, I'm going to say, based on the best practices you have, could you ultra think? Now, the word ultra think is a bit of a key word for Claude. It makes it really think. No idea why. This seems to have been the case with all AI models since ChatGPT first came out. If you ask it to think deeply, it does a better job than if you don't. So I'm going to say, could you ultra think about some potential improvements to this code base? And I'm going to ask it actually can you write your suggested improvements to a folder called suggestions and write one suggestion per file. Could you at most create 2 suggestions? I'm constraining it there just to save a little bit of time. And then I'm going to say, can you rank these suggestions in order of priority? Ensure you cover things like performance, security, and general .NET code best practices. I've got plan mode enabled here. I don't want Claude actually making any changes. I'm just asking Claude to look at my code base, look at the best practices it understands about using .NET code, and actually suggest any improvements to the code base. While that is just pulling them suggestions together, let's go and have a look at how our little serverless scaffolder is coming together. It's about halfway through its to-dos now. Whilst that's just doing that, let's just go and have a look at what it's actually created. So it's created a whole bunch of tests, which is good. It's created my core business logic. It's not started on the API yet, which is fine, but it's working through and it's slowly getting things done. Okay, so Claude has now finished writing suggestions for me. Let's see how bad of a developer I am and see what Claude thinks I could do better. So looking at in my directory, I should now have a suggestions folder, which I do, and it's created at most 2 suggestions ranked by order of priority. So there's some security and performance critical fixes. Oops. And there's some code quality and architecture fixes. So let's have a look what Claude has written. So it's saying that there's some security vulnerabilities in that I'm setting cores to allow all. That's fine because this is a demo app. It's recommending that I actually add cores and get very specific, which is cool. I'm exposing a connection string in my logs. Not ideal. And let's have a look how I'm doing that. Okay, this is I'm loading it from SSM. That's probably a leftover from me testing some things. I've got some blocking asynchronous operations. I've got some missing authentication authorization, and I've got some inconsistent date time usage. So Claude has identified all these things across my code base and actually recommended some next steps that I should do to actually take action. Looking at the second one, code quality and architecture improvements, enable nullable reference types. This is a really good idea in .NET if you're not familiar. I've got implementing the result pattern for event handling. This is something I love after writing a lot of Rust application code, is the result pattern as opposed to just throwing exceptions. So big fan of this Claude, recommending that I implement result. Replace Newtonsoft. This is also generally a good idea. So if you're not familiar with .NET, Newtonsoft.json used to be the library that you used for JSON serialization and deserialization. That wasn't actually built natively into the .NET runtime. Then in .NET, whatever version, Microsoft added the system text JSON, which is native support for working with JSON. So really, you should replace Newtonsoft JSON with system text JSON. That's a good suggestion. Again, Claude, standardized testing frameworks. I've got various things going on with fluent assertions, with fake it easy, with mock, standardizing across the board there, which sounds good. Domain events, yep, great. So what we're seeing here is that, interesting, implement strongly typed configuration. So there's some really interesting stuff in here. So this is the third way I'm finding myself using AI, is actually to look at a code base as a whole, look at some best practices that I've identified that are generally best practices in the industry, and use that to actually suggest improvements to my code base. Now, some of these I might ignore. Look, I know this is a demo app. I know that having cores allow all is generally a bad practice, but actually this is just a demo, so I'm okay with that. I can get rid of that. Exposing a connection string in my logs should probably fix that one. So it's a really good way of using Claude to actually summarize your entire code base. These AI models are really good at giving them lots and lots and lots of context and saying, hey, can you summarize this for me and draw out some insight, which is exactly what you're using for here. Notice I'm not asking Claude to go off and immediately fix all the problems. I'm asking it to write the things it would do, the suggestions to a file. I can then review them suggestions manually. Okay, now Claude, can you go and implement priority 1 inside the security and performance critical fixes file? And Claude will go off and do that. I can iterate, I can commit that to GitHub if I'm happy, and then I can start afresh whenever it comes and starts the next fix. Let's see how our code gen for our serverless app is coming along. I think it should be pretty much done now. It looks like it's finished. Yep, so it's at the point where it's setting up SAM templates, which means all of the code should now be written. So let's actually have a look how it has structured this project and see if it's something I would do. So it's got the SAM template at the top level, which has got, looks like a pretty good structure. It's created the contacts table. It's created the function, it's set the runtime, what does it set the runtime to? .NET 8, okay, that's fine, it's using native AOT, so that should work. I've got my 2 functions, I've got the actual API itself. Again, SAM doesn't necessarily need you to explicitly create the HTTP API because it would auto create that, but I'm fine with that as far as a scaffold goes. Creates my log group. Again, creating my log group manually is kind of useful because I can set the retention. Let's have a look at the actual structure of the project now. So I've got my source folder with my adapters, with my DynamoDB repository, which is using the low-level DynamoDB client, which I like. It's using a put item request there. It's using a get item request there, an exists call, and it's got a mapping layer, which is all good. Let's have a look at our actual Lambda functions now. If I look at my contact function, it's using the Lambda annotations framework, which is great. It's saying there's a post method on /contacts. This is not really doing anything apart from parsing the inbound request. That's kind of cool. So it's set up structured logging and it's auto added the contact name and the contact email to my logger. Now, generally, I probably wouldn't want to do that. This is where I would go. At this point, I would now go back to my initial Claude.md file and prompt it to not write sensitive or PII information into logs or traces. So I'm going to delete that because I don't want my contact name and my email inside my logs. And all this is doing is calling into my contact service and saying register contact. So if I go and look at my contact service now, which I'm assuming is going to be under my core library, which it is, which is good. Things are in the place I expect them to be. This is my actual business logic. It's validating the inbound request. It's creating the contact. It's calling into my repository. So this is generally the structure that I would go for if I was creating a .NET Lambda project. It's also set the target framework to .NET 9, which is fine, and it's set up native AOT compilation, trim mode to pull. So this is actually scaffolded a serverless .NET project in the way I would scaffold a serverless .NET project. Now, I'm not saying this is the way that you should do it. You might have a slightly different opinion on how to structure a serverless project, how to structure a project, but this is how I would want to bootstrap a brand new application using things like ports and adapters, separating business logic from infrastructure code, and it's really just saved me a whole lot of typing to type a lot of boilerplate. This was made possible because of the amount of context I gave to Claude in the first place. So just to recap the 3 ways in which I'm finding myself using AI more and more. The first is bootstrapping new projects. Now, I'm doing that with a lot of additional context, these enormous context files that Claude can load up into memory and use that to actually guide its behavior in terms of how it actually does things. This saves me writing an awful lot of boilerplate code, and if I have a rough idea what I want the application to do, I can at least get started and I have something to work from to iterate on. Secondly, I'm using it to help diagnose issues. Remember, I'm not using it to fix the issues immediately. I may end up using it to fix the issues, but I'm not doing that straight away. Instead, I'm giving Claude error, an exception, something that's happened in my application. I'm saying, look at my application code, here's the error message, can you work out where the problem might be? The reason I'm doing that is that Claude doesn't have the historical context of how a code base ended up in the state that it's in. Maybe there was a really weird edge case feature that the CTO asked that I add 6 months ago that looks like it might be structurally incorrect or looks like that it might be an error. Claude might just go and remove that if I let it free to fix issues. So I'm asking Claude, hey, here's an issue, where do you think the problem is? And then finally, I'm using it to suggest improvements to my code base. These large language models are very good at taking a lot of information and summarizing that information. And that's exactly what I'm doing with my code base, plus these additional context files that have all the best practices that I think should exist for these kinds of projects. I can give that to Claude and say, hey, look at my code base. Can you suggest any improvements? Now, one thing you'll notice in all 3 ways that I used AI is that I am not just asking Claude to go off and build stuff. I'm not vibe coding, as all the cool kids are calling it. I'm asking Claude to create a plan. I'm going to review the plan and say, hey, is this something I actually think you should do? And if I agree with the plan, I'm going to let Claude loose to actually go and implement these things. Now, the other thing that is really, really valuable, no matter how you're using these AI tools, is to actually commit the code to Git. Even if this is just like a little temporary project that you may throw away at the end, having Git integrated allows you to understand exactly what an AI has changed. Commit my code to Git, I have a fresh local instance of my Git repository, I ask Claude to go and make some changes, I can simply look at the diff to understand exactly what Claude has changed. If I'm happy with what Claude has done, I can commit, I can ask Claude to do some more work. And the funny thing is, and this isn't a fresh or interesting take, this is something that has been posted numerous times around the internet, is that actually these are just best practices for modern software development. Small commits, doing things in small batches, writing a lot of tests, thinking about best practices, thinking about architectural structure, all these things are things that we are doing anyway. We're just now asking an AI to take off some of that burden. So remember, ask the AI to plan first, review the plan. If you're happy with the plan, let the AI actually implement, and commit often. If you commit often when it comes to understanding exactly the lines of code that an AI has changed, you can do that by simply looking at the diff inside your IDE. That's how I'm using AI in my day-to-day. I appreciate this is probably a bit more of a random all over the place video than you might be used to from this channel, but I hope this has been useful. If you're thinking about vibe coding, you're thinking about how you can start to bring AI into your workflow, I hope this has helped you at least get started. Those developer prompts that I showed in the video, they're in the GitHub repo below. This is all public, that's all available. If you're going to use them developer prompts that I have on GitHub, make sure you don't just copy and paste them exactly as they are. Read them, understand them, tweak them to meet your specific requirements, and use that to help you get started, not just blindly using the thing that I've used. I hope this was useful. If you want to talk about how you're using AI, I'd love to see your opinions in the comments below. And with that, I will see you all in the next video.